Radiological risk assessment is a process used to evaluate the potential risks associated with exposure to ionizing radiation in the workplace or in the environment. This type of risk assessment is typically performed by trained professionals, such as radiation safety officers, and is based on established scientific principles and data. The goal of radiological risk assessment is to determine the likelihood and magnitude of potential harm to individuals or the environment resulting from exposure to ionizing radiation. The assessment typically involves the following steps. Identification of sources of radiation. The first step in radiological risk assessment is to identify the sources of ionizing radiation that could cause exposure. Estimation of radiation dose. The next step is to estimate the radiation dose that could be received by individuals or the environment from the identified sources. This is typically done using mathematical models or direct measurement. Evaluation of health effects. The estimated radiation dose is then evaluated in terms of the potential health effects that could result, based on established scientific knowledge and data. Development of control strategies. Based on the evaluation of potential health effects, control strategies are developed to minimize or eliminate exposure to ionizing radiation. Monitoring and review. Radiological risk assessment is an ongoing process that requires regular monitoring and review to ensure that the control strategies are effective and to identify any changes in exposure levels or health effects. Radiological risk assessment is an important tool for protecting workers and the environment from the harmful effects of ionizing radiation. It is used in a variety of industries, including nuclear power, medical imaging, and industrial radiography, among others. Compared to determining the risk associated with chemical exposure, radiological risk assessment is generally more straightforward. This is because the interaction of radiation with tissue occurs directly without intermediate processing and can be analyzed using well-defined dosimetric concepts. Dosimetry refers to the measurement or estimation of dose within a given tissue and is central to any form of risk analysis. In radiological risk assessment, dosimetry is found in its most direct and simplest form. As a result, the biological effects of radiation exposure have been investigated more thoroughly than those of virtually any other environmental agent. This is particularly true for exposure to high doses, where measurable levels of cancer and other adverse health effects have been observed. The knowledge gained from radiological risk assessment has been influential in shaping human health protection measures for many other environmental hazards. The process, or paradigm of risk assessment as applied to ionizing radiation typically involves the following 4 steps or phases. Hazard identification. This step involves identifying potential sources of exposure to ionizing radiation and the associated health effects. Dose response assessment. The next step involves estimating the relationship between the amount of radiation exposure and the likelihood and severity of health effects. Exposure assessment. This step involves estimating the levels of radiation exposure that individuals or populations may receive from the identified sources. Risk characterization. This final step integrates the information obtained in the previous steps to provide an overall estimate of the risk of adverse health effects associated with exposure to ionizing radiation. Once the risk assessment is completed, the results can be used to develop risk management strategies to reduce or eliminate exposure to ionizing radiation. Risk communication is also an important part of the process, as it involves informing stakeholders, including workers, the public, and policymakers, about the risks and how they can be managed or minimized.